All right, so we are going to look at the first day of EOC review, and we've got a few problems here to go over. You will have a Canvas assignment that also has problems with similar problems, at least. There'll be different numbers, different equations. So we're going to take some notes on these as well. So on the first problem, it's slide 2, it says which equation is the inverse of y equals 13x plus 2? So one thing I want you to do in that box is type a note about finding inverses. Okay, so to find the inverse, we switch x and y. That's to find the inverse. So remember, we found inverses in several units. We found inverses of different types of functions, and every time we switch x and y. So if we do that with the equation they gave us, we switch x and y, x equals 13y plus 2. And then the second thing we do after you switch x and y, you solve for the new y. And then that's your answer. So we'll subtract 2. X minus 2 is equal to 13y. And then to get y by itself, we will divide. So the 13's cancel, and y is equal to x minus 2, all divided by 13, which is answer choice C. Okay. So at least on your slide, you need to have these two instructions, switch x and y, the solve for y, and then the answer is C. Okay, if you want to type the work in as well, you can. If you want to write that down somewhere, that's fine. Okay. All right, next problem says find the negative member of the solution set for, and it gives us an equation. So in this equation, it has absolute value bars. So remember when we solved absolute value equations, we get two answers. So absolute value equations have two answers. So that's the first thing that's important here. Now they are specifically asking for the negative, it says negative member. That just means the negative answer. So we'll find both the answers, and then they only wanted the negative one for this. All right, so to find your solution set for absolute value, first, we isolate the absolute value, which is already done for us in this problem. Remember, we want the absolute value alone on one side of the equation, which is already done. And then we split into two equations. Okay. So to split into two equations, the first equation is exactly what it says without the absolute value, 2x minus 4 equals 6. And then the second equation, the absolute value stays the same, but this time, remember, it's equal to the negative 6, negative answer. And then you solve both equations separately, right? And you'll get your two answers. We'll solve this one. Right, and then normally it's just asking for the solution set. So they would write the solution set in those curly brackets, and they'd put both the answers like with a comma separating them. Remember, we see that sometimes. But they didn't ask for the solution set. They said the negative member, the negative answer. So the only one of these answers that's negative is -1. So that's the one that they're asking for. So the answer for this problem would just be -1, since they're only asking for the negative. Okay. But again, if they were asking for the whole solution set, you would see it written in these curly brackets. All right, next problem is on slide 4. We see absolute value again, but this time we see inequalities. So for inequalities, some things to remember. Less than or the less than equal to. So less than or less than equal to. Those are going to be where we shade in between, or they have and with their answer sometimes. Okay. We shade between the numbers. And then the second thing to remember is if it's greater than or greater than equal to, and since you can't type the equal to, you can just type the less than and the greater than in the box, that's fine. These have or in their solution, and we shade to the left and right of the numbers. So we'll talk about what that means when we solve this one. So when we go to split this one up, we again isolate the absolute value first, which is already done for us. And so when we split into two for this one, when we did less thans, we wrote our answer a lot of times like this, where we have x plus 1 less than 2. We would actually take the -2 and write it as a compound inequality that looked like this. Some of you preferred, because this only works for less than, so your other option is to do x plus 1 less than 2. And then remember, x plus 1, to get the second one, you would switch the sign and the number with inequalities. You switch both of them. And then you go off of what we just said. If it's less than, you put the word and. So this is a less than, so we would put the word and in our solution. If this original symbol had been a greater than, we would put the word or there, and that tells us how we're going to shade. All right, so either way, when you go to solve, if you solve a compound, then whatever you do to the middle, you do to the left and the right. So we get -3 less than x less than 1. If you're solving it this way, remember that this would mean because it's less than and doesn't have an equal to underneath it, that's open circle, not closed circle, which all these answer choices have open circles, so we didn't have to worry about it this time. And then you find -3, put an open circle. Find 1, put an open circle. And then because it's x is in between them, or because it's an and, you shade between -3 and 1. So the answer choice is A. If this had been a greater than problem, then the answer would have looked like C. So if this had been like x plus 1 is greater than 2, that's where we would shade to the right and the left. Okay, and those are the ors. But this was a less than, so you shade in between them. So answer choice A. Okay. Next one, we are going to need decimals for this. So it says find the sum of the x coordinates. So sum means add, and then x coordinates where f of x is equal to g of x. So if you see this, f of x equals g of x, and they give you two different equations, but remember, sometimes they will actually use the word system instead of, they'll say like solve the system. You need to graph both in Desmos at the same time. So let's do that now, okay? Let's graph these in Desmos. All right, so right now you see I've got my equations typed in Desmos. Again, you type both of them in at the same time. And when you're solving a system, you're looking for where the two graphs intersect. And so I see they intersect here at 0, -3 and 1, -4. 0, comma, -3, and 1, comma, -4. So those are the 2 points that, that this graph intersected at. So if it's asking me for the sum, that means add the x coordinates, then I'm only going to add the x's. So my x's are 0 and 1. So 0 plus 1 is just 1. So anytime they're asking about a systems question like this, you graph both in Desmos and you find the intersection, or intersections, usually it's 2. And then you just answer whatever the question is. Again, this time we were asked for the sum of the x coordinates, but they could have asked me for the points. They could have asked me for both of them. They could have asked me for something about the y coordinates. So graph both in Desmos and then find points of intersection. And then you can answer the question like we did. So the answer here is 1. All right, next, what is the range of the function f of x equals -5 minus 2 times x plus 3 squared? If I'm answering range are y values, and I need a graph. A lot of times they will give me a graph, but they did not on this one. So since they did not give me a graph, the very first thing I'm going to do is go to Desmos and type this in. All right, go to Desmos and type this in because I want a graph. All right, so here I have typed in my function that was given to me in Desmos. I can see it is a parabola that is pointing down. And it is asking me for the range. So remember, range are the y values. And we always go bottom to top for range. So it is going down forever and ever and ever and ever and ever and ever and ever. It is going down, which means it's going towards negative infinity. And the highest y value is right here at -5. Remember, range is y values. That point, the y value is -5. So when we go to write the range, the highest point comes second, the lowest point comes first. If your graph is pointed towards negative infinity will always be the first thing you see. You'll never see negative infinity as the second part of your answer. And then again, we said range goes bottom to top. So since the highest number was at -5, -5 will be the second thing that we see. So it's going to be negative infinity to -5. Okay, so I would write a note there, just in general, that range, we look bottom to top. And just in case they ask about domain are the x values, and we look left to right for that. Okay. Negative infinity will always be, if it's in your answer, it will always be the first thing that you write. So this answer is negative infinity to -5. The bracket, again, just means that it touches at that number. Okay. This one gave us a graph, so we don't have to graph it ourselves. It says give the intervals that the function increases and or decreases. So as I'm looking at this graph, I see that it is going left to right. This graph is decreasing. The y's are going down for this section. At this point, we'll worry about what we're writing about that point later. The graph starts to increase as I move to the right. So as I'm tracing this graph, I'm increasing, I'm increasing, I'm increasing, my y's are increasing, and then they stop increasing right here. And then my graph, my y's, they start to decrease until the end of the graph. So I can see that this one increases and this one decreases. When you answer increasing and decreasing, you use X values in your answer. This is where some of you got confused when we learned increasing and decreasing this year. You only worry about the X values in your answer. So what we would say about this problem is, like this purple that I've got on my graph was decreasing, we would say it decreased, and we use the X values. It decreased from when X was -3 until this point when X was -2. So it decreased when X went from -3 to -2. At -2, the graph started to increase. And it increased from -2 until X was 0. So -2 to 0. And then it decreased again. This section's decreasing. So it's going to decrease from 0 until X values. This point has an X value of 1. Never use the Y values when you're writing your answer. Okay? Always use X values when you're writing your answer. Now, a lot of our graphs only increased or decreased at one place. This one decreased twice. That's okay, that can happen. Okay. You also only use parentheses, never the square brackets for increasing and decreasing. So you don't have to worry about which to use. You only use the parentheses for this. All right, and our last one deals with piecewise. Right, piecewise. It says evaluate, and then it gives me this expression, f of 5 minus 3 times f of 3 plus f of -3. Now the numbers in the parentheses, they represent X values. And remember, we had to determine in piecewise, we have several pieces of the graph. That's why it's called piecewise. And we have to determine which section these numbers fit in. All right, so the first one, f of 5, let's do that first. And then we can do our final answer at the end. To find f of 5, first we have to decide, is 5 less than -2? No. Does 5 go between -2 and 3? No. 5 is greater than 3. So I'm going to use this one. So that means I actually plug 5 in for X here. So instead of -X plus 4, I would plug a 5 into that and get my answer. So you would type in -5 plus 4 and get a number back. So f of 5 is just -1. Okay, so remember, we would just write that like underneath it. And then we'll bring down this -3, and we need to find out how much f of 3 is. So that's the next thing we're going to do. F of 3. And then I see 3 in both of these. Remember, we used the one that has the equal to. This is the one that 3 is going to fit in. This equation does not have an X, which means the answer is automatically 3. I don't have to plug in anything. And because up here it says -3 times f of 3, I've already written my -3. I'm just going to write the 3 that we got. Remember, we do this at the end in the calculator to get our final answer. All right, last one, plus f of -3. So we need to figure out how much f of -3 is. -3 is less or smaller than -2, so it falls in the first one. So I would plug -3 in for X. If I do 2 times -3 minus 1, I get -7. So f of -3 is -7, so I'm going to plug that in here. So to find my final answer, this is what I'm typing in my calculator. -1 minus 3 times 3 plus a -7. and that's going to give me the final answer, okay, which is -17 for this one. So my answer for this is -17.